students, welcome back to our next video on rocks. And we're going to cycle right through this video fairly rapidly as you complete a diagram in your notes. This video today is about the rock cycle. And so I believe I've given you the skeleton of this diagram in your book, but you're going to be reproducing it, the details in your book. You don't have to worry about copying this all down right now. There's a lot of information on this diagram of the rock cycle, but I am going to take you through it one step at a time. So let's examine the rock cycle. And before we even begin, let's just briefly talk about the word cycle. The word cycle means to go around and around and around, like a bicycle wheel that has spokes attaching the hub to the rim. But the mere name cycle means that something repeats itself over and over and over again, like the water cycle goes around and around. Keep that in mind as we talk about the rock cycle, because as we do, I'm going to start us in a particular location, but I want you to remember that there really is no one starting point of the rock cycle because it's continuous. Wherever we begin the rock cycle and end the rock cycle in this video, please know that it continues to go around. It doesn't stop at the end of the rock cycle. It continues. But we do have to start it somewhere, so we're going to start it at what I think is a logical beginning point, and that is magma and lava. So in your diagram, if we start at the bottom of our diagram, we're going to label that circle or ellipse or whatever we'd like to call it, magma and lava. That is molten rock. That is going to be our starting point. And you might guess that on our diagram, these three rectangles are going to become our three rock groups. So we're going to begin by drawing an arrow from our magma and lava, from our molten material. We're going to draw an arrow to our first rectangle. And along that arrow, we're going to label that arrow cooling and crystallization, or crystallizing. Cooling and crystallization. Now, I want you to think about this before I give you the answer. When magma or lava cool, they are going to crystallize and solidify into one of the three groups of rocks. What do you think it's going to be? Well, if you said igneous rock, you are exactly correct. Think about the definition of igneous rocks and the description from the previous video. So igneous rocks are formed from the cooling and crystallization of magma and lava. And remember, magma forms intrusive igneous rocks, lava forms extrusive igneous rocks. Now, rocks are rocks, and whether we're talking about igneous rocks or other kinds of rocks, when they are rocks, they undergo weathering and erosion. Leave a rock outside long enough, and it's going to weather and erode. Nature itself here on planet Earth, every time it rains, every time it snows, every time the wind blows, anytime there is activity in the atmosphere on the surface of planet Earth, there's going to be weathering and erosion of rocks taking place. The waves crashing up on a rocky shoreline is another example of weathering and erosion. So make sure that your arrow is not only drawn, but you label it weathering and erosion. And whenever we have rocks that are weathered and eroded, we have the formation of sediments. Remember that sediments are small particles from eroded or weathered rock material. So when we've got an igneous rock that undergoes weathering and erosion, we have the formation of sediments. And this brings us to the next part of our rock cycle. This is a fancy word, but you should be familiar with it. It's called lithification. I love that word. Lithification. To lithify something is similar to the word petrify something. To petrify something, you might know, if you think of petrified wood, means to turn it into stone. Lithification means the same thing. To lithify means sediments turning into stone under the process of lithification. And when sediments are lithified, they can do that in different ways, chemically or in other ways. Think to another video we may have watched. But what rock group do you think is formed from the lithification or the turning into stone of sediments? Take a guess. If you said sedimentary rocks, you're absolutely correct. Yes, sedimentary rocks are formed through the lithification or the cementing together of sediments. Yeah. But here's the deal. We're not done yet, because sedimentary rocks, as cool as they might be, can undergo changes. And there are different kinds of changes that can take place as you're drawing this arrow from sedimentary rocks to our third rock group. And along your arrow, you could be writing heating, pressure, and chemical changes. There are a lot of different kinds of changes that can take place to sedimentary rocks as they are squeezed or heated or chemically changed into our third rock group. And take a wild guess as to what you think that third rock group might be. Yep, it is metamorphic rocks. So here we have our three rock groups: igneous rocks, sedimentary rocks, and metamorphic rocks. But as you can imagine, we're not done yet, because metamorphic rocks can find themselves in locations where they will undergo dramatic heat, like near a plate boundary or near a volcano or a magma chamber. And those metamorphic rocks can melt. And if those metamorphic rocks end up melting, guess what they form? Either magma or lava. Magma if it's beneath the surface, lava if it's above the surface. So you can see how this cycle has gone, so to speak, full circle from magma and lava back to magma and lava. But it's more like a bicycle wheel than just a circle, because the rock cycle isn't complete at this time yet. Why? Because it's not a straight line that exists from one rock group to another. Check it out. Think about this for a moment. Igneous rocks can also undergo dramatic changes of heating, pressure, and chemical changes and turn into metamorphic rocks themselves. So you can go from igneous rocks to metamorphic rocks. Igneous rocks can also find themselves near a plate boundary or a volcano, and they can turn back into molten material. It happens all the time. And then cool back into other kinds of igneous rocks. But it doesn't end there, folks. Check this out. Sedimentary rocks. Sedimentary rocks cannot just be heated and undergo pressure and chemical changes and form metamorphic rocks, but sedimentary rocks can melt themselves and turn into magma or lava. Sedimentary rocks themselves can undergo weathering and erosion, turn back into sediments, lithify, and turn into other sedimentary rocks. Yes, but it doesn't end there either. Yes, there's more, because metamorphic rocks can also undergo weathering, and undergo erosion, turn into sediments, and turn into sedimentary rocks. The point is, and I'm out of breath. The point is, though, that all three rock groups can undergo all three of these changing types in the cycle and form different kinds of rocks. It's more like a web that exists, or I like to see it as spokes of a wheel. And all of these changes that take place are part of the rock cycle itself. And so, if I were to give you a diagram like this, or if you started with a blank diagram like this in your book, you should be able to fill in the outer rim first, and then be able to fill in the processes that take place, the magma and the lava and the sediments, and then fill in the rock groups, the three main rock groups. So I would challenge you to study the diagram of the rock cycle. It will help you understand what is happening as nature takes one type of rock group and goes into another type of rock group by the various processes that continuously happen every day here on our lovely planet Earth. So until next time, I'm going to say bye bye.